Hi everyone, in this video we'll be going over runtime analysis of different Python functions. For the first one, we have a function called counter squared that takes in a list, and we can see that it has a loop inside. And since LST have n list of elements, we know that this loop will run in n times. And since we're only running multiplication inside the loop, we're actually only performing in constant time. And since there's no listed loop, like another for loop inside of this for loop, the overall complexity will be big O of n. Okay, let's go to the next problem. Taking a look at a random function, the outer loop runs n times, and the inner loop runs I times. And inside a loop, we also have a call to sum, which also iterates over n elements. So if we count how many n elements there are, and we multiply them, then we get big O of n to the power of 3. For the next problem, let's compare random function new to our random function. Okay, so what has changed? Everything is the same except the fifth line that has been changed to from this to this. And how will the runtime of the new function change in relation? Let's try doing what we did in the previous problem to this problem. So we have a for loop I, and then a for loop j, and then finally we have the actual code. So here's the change. Instead of calling this part where it was n times, now we just compute this part, which is only constant times. This means that we only have two n's here, which makes it big O of n to the power of 2. And this is more efficient than n to the power of 3. So we can get that this new function is more efficient than the previous function. Let's go to part D. Notice in this expression how n is repeatedly divided by 2 in the while loop. This means that the iteration follows a logarithmic pattern where each step reduces n by half. So this means that we'll just have a big O of log n iterations. Now we have the last part of our question. Here we have a filter function that selects n divided by 2 even numbers. Here's where it's trying to figure out even numbers, and this means that it's big O of n times. So then we have another map function that takes in the filter function as a part of the lambda. And the operation we do is x to the power of x, and this is in constant time for each of the big O of n operations. So thus the total complexity for this is big O of n and not n of 2, of n to the power of 2, because we're not really nesting loops here.